Hi, Assalamualaikum. What's up, guys? This is a quick summary of Chapter 5, Dynamics and Static. Let's try to recap what we learned in Chapter 3 previously. I have informed you about the meaning of dynamics, right? Which is dynamics deal with the effect of forces have on motion. So, what is force? Force is what causes motion on object. Okay, these learning objectives for this chapter. First, application of Newton's law. Draw free body diagram for physical system. Apply the second law to an object in equilibrium. Apply the second law to an object under acceleration. And apply the second law to system of two objects. The second learning objective is about forces of friction. First, you able to explain the physical origins of friction forces. You able to apply the concept of the kinetic friction forces, apply the concept of the static friction forces, and the last one is apply the system approach to multiple body problems. Alright, class, this is the chapter outline that will be taught during your upcoming lecture. There are two large subtopics that will be touched, which are effect of force related to Newton's law and friction. Alright, in the first 5 subtopics, we will be learning about how to calculate net force and how to draw free body diagram. After that, weight, gravitational forces, the physics of standing still, the inclined plane, and tension force. Alright, in the subtopic of friction, okay, you will be learning about kinetic friction force and static friction force, how to calculate between kinetic and static friction force. Okay, in this first slide, okay, you will learn how to apply Newton's second law, which is to calculate the net force. We know that the second law, second Newton law is F is equal to ma. To find the net force, alright, to find the net force with angles, we must break into two components, okay, which is X and Y components. Okay, you will also learn how to draw free body diagram. Okay, this is example of free body diagram. Okay, refer to this block. Alright. Okay, this lecture also be giving you a few cases examples, okay, to difference the method in drawing free body diagram. Is a second example, okay, the normal force on a level surface with and apply forces, and is third case. Okay. Next, in the subtopics such as inclined plane and tension force, is inclined plane. Okay. Is tension force. You will also learn ways to calculate net force for every situation given. Okay, for example, this is a situation of case. Refer to tension force. We have a vertical tension force, okay, vertical tension force on accelerating object. This is a third case about two tension force at symmetric angles. And these last cases about two tension at non-equal angles. So make sure you know how to calculate and break down the vector component X and Y component. Alright, then we will learn this some example. Okay, make sure you do the example. Okay, Then you will learn about friction. Make sure you know how to differentiate between kinetic, okay, between this is about friction. Okay, what is friction? Okay, between static friction, okay, static friction, and kinetic friction. Okay, is kinetic friction. K-I-N-E-T friction. Okay, kinetic friction. Okay, kinetic friction forces. This is the equation. Okay, this equation to calculate the kinetic friction, which is Fk. Fk is referred to friction force. K is kinetic, equal to mu k times, and this reaction force or normal force. Okay, mu k is a coefficient of friction. The equation in the kinetic friction forces is the same as the equation of static friction force, but the kinetic friction, the static friction force is Fs equal to mu s times, and the difference is just value of s and no value, the symbol of s and mu s. Okay, same equation, right? Okay, same equation. Okay, this is the value of coefficient of friction for static friction and kinetic friction. This constant will be given during exam, so you don't have to memorize for exam. Okay. Alright, in general, this chapter will not have any new formula to learn, just practice calculating and breaking the vector. Okay, this problem solving strategy. Okay, first when you get the problem solving, so make sure you read the problem, draw the picture of the system, label your picture, draw a free body diagram, apply Newton's second law, and solve. Alright, that's all for the summary of chapter 5. See you in lecture soon. Thank you.